Hello everyone, welcome to the another very important session in which we will be discussing about some more important questions and very important concepts of quantum mechanics. Let me just quickly have a look at that part, like whether everything is all right and clear in the session today or no, and then we are going to go ahead to do more discussion in the session. So I'm just quickly going to check it out, and then we are okay. I think everything is all right and clear. Okay, that means we can continue the discussion and we can start it. Okay, guys, so today we will be talking about the important concepts of quantum mechanics. And along with these questions and concepts, I'll keep on sharing the tricks as well wherever they will be possible to consider. Okay, so guys, let me just show you some important slides first of all, and after that, we will be continuing the discussion. This is the first one. This is the next slide we are going to have regarding the session itself. Okay, this is about the Unacademy learning app, and this slide is going to share some information about me. This is regarding the community feature we are going to have on Unacademy, okay, which will be helping you to get the latest updates and the information. So in that case, if you're the one who wants to know about the new courses, the latest information and updates, so it will you in that way. Also, guys, I'm gonna share more important slides with you, and these are going to be related to the important courses we are gonna have and the different subscriptions. So basically, this is regarding the iconic subscription. If you want to take the iconic subscription, then it will be helping you a lot to understand that what are the. Give me a second, guys, just a second. Okay, yeah. So what are the benefits you will be getting? And how it will be helping you, right? So this is what you can get to know from this particular slide. Once you're going to get all these details, you need to know one more thing. Whenever you will go ahead to take the subscription, you can use and apply the code that's Anjali Live, as even it has been mentioned here on the screen. So anytime, even if you are going to take the subscription or any of your friends are going to take the subscription, they can use and apply the code that's Anjali Live as mentioned here on the screen, as it will be helping them to even get the discount in the total subscription amount. This is regarding the plus subscription. Also, guys, now notes are even available on the learning app. So if anybody will be taking the subscription, they will even be able to get the important notes, and that will be helping them as well. Hello, Deepika. This is regarding the plus subscription. So even in the plus subscription, the important notes will be available. Okay, to anyone who will be taking the plus subscription. This is regarding the light subscription, and the difference between the plus iconic and the light subscription has been shown here. So in the plus and the iconic subscription, you will be able to get the important notes too. And this is how, along with the important questions and concepts and many important benefits which you are getting in the respective subscriptions, all these things will be helping you to take your preparation to a very good level. Okay, guys. So we are now ready to take some questions from the quantum mechanics part. And if in case you are going to have any doubt anywhere from the question part, from the concept part, from the discussion, or the tricks we will be including, you can surely let me know about it, and we will try to consider those points here in the session. Okay, guys? So we are gonna now continue the discussion. Let me just give you the first question right now. Even in upcoming days, so many new courses by the top educators will be starting on Unacademy. So if you don't want to miss these important courses and the classes by the top educators, you can surely take the subscription and use and apply the code that is Anjali Live, as I have shown you on the screen. So by using and by applying this code, you will be able to get the discount in the total subscription amount. Okay, here is your first question, which is waiting for you. So let's see how many of you will be able to work on it and get the answer for this question, guys. The question is, let A and A dagger, hello Tina, respectively denote the lowering and raising operators of a one-dimensional simple harmonic oscillator let N be the energy eigenstate of the simple harmonic oscillator given that N is also an eigenstate. If something will not be clear to you anywhere, you can surely tell me and I'll just make it clear to you. Also an eigenstate of A dagger, the corresponding eigenvalue is options are n times n minus 1, n times n plus 1, n plus 1 square, and simply n square. So let's see how many of you will be getting the answer. Who will be getting the answer, guys? Just mention what is the right option according to you in the comments, and I'll just let you know whatever clarification will be needed and whatever steps you have to take to solve it. So giving you some time and waiting for your response in the comments. After that, I'm quickly gonna start the discussion and will be telling you about the steps for solving it, and waiting for your reply now. So if you want to ask anything about it or something is not getting clear, just let me know. I'll talk about that part. Nobody has given the answer in the comments till now, guys. Waiting for the reply. Nobody has given the right answer till now. So waiting for your reply again. I just want to give you a chance, like if you can try and you can reach to the answer, that will be great. Okay, Liana has just now mentioned it will be option A. Very good, Liana. That's great. Okay, just in few seconds, I'm gonna continue the discussion, guys. Only one right answer means one answer particularly in the comments. Okay, let's go ahead to solve it and just to see what is the exactly right answer. Okay, now guys, so what question is asking you? It's given let A and A dagger respectively denote the lowering and raising operators of a one-dimensional simple harmonic oscillator. Let N be the energy eigenstate of the simple harmonic oscillator given that N is also an eigenstate of this. Okay, eigenstate of this means the n is not getting changed itself, right? N state will be remaining the nth state and it's not gonna become something else. Done? So that is the meaning of eigenstate. Very good, Kalyani. That's great. So let's consider this as the given operator, the overall operator which is given to us, and we will operate it on n. So we know even in the question they have explained this is lowering operator, this is lowering operator, this is raising operator, and this is raising operator, right? So in this case, what will happen? When your first lowering operator is going to operate on the nth state, what it will give you? It will give you square root n and n minus 1, because that's how it operates, right? We call it the lowering operator because it lowers the state by 1. So your n will obviously be becoming n minus 1. But what else you will have there? Whatever is within this state part or whatever state is there is square root of that value. So have a look at this. A dagger, A, root n and n minus 1. This is what you will get when you are going to operate the A operator on the nth state. Same way, when you will operate A on this state, what will happen? Square root of that value you will have there, and this will lower by one more value, so it will give you root n minus 1, and this will give you n minus 2. That's what you will be getting now. Now you are having the raising operator present there. So what does it do? Whatever is within this state, you will add 1 in it and take its square root, and also for the state it will increase the value by 1. That's why we call it the raising operator. So it's going to basically give you this root n minus 1, and one more root n minus 1, because you will add 1 in this value and it will give you square root n minus 1, and when you will add 1 in this one, it will still give you root n minus 1th state, right? That's what you are gonna get. Now it's the turn for this A dagger, which is your raising operator. When you will operate it here, what it will give you? So it's simply gonna give you the root n, because you will add one value in it, and that's how you are just gonna get it here. That's going to be square root of n minus 1 plus 1, that is the square root n, and again you will have to add 1 in this value, so it will give you this value right here. So it's giving you root n square, root n minus 1 square, which is n times n minus 1, and this is your nth state. That's it. So this is overall operator, this is the value you are getting. So what is the right answer? What is its eigenvalue? It's option A, which is the correct one. Tell me if in case you are having any doubt anywhere right now, or you are confused about the operators, how they are working, or anything you want to ask, you can surely let me know about it and I'll just make it clear to you. But if it is clear, the next question can help you to get a concept in a better way if you have any confusion in that. And these questions which I'll be taking here will be either from the NET previous years, GATE previous years, or whatever we expect and we get in the NET and GATE similar to that from the JEST exam. Even we can include the questions to practice in the session today. Okay, so let me just give you the next question right now, and all the questions and concepts are very much important for your NET, GATE and JEST exams. So yeah, you can get great idea about the quantum mechanics concepts, questions, and so many things we will be including in this session. So a quantum particle, even if somebody is there who has not prepared all these topics and attending this session, can exactly get an idea that what they can expect in the exam and from which section the questions can be there in the exam. It's a good thing to do before the exam. A quantum particle is subjected to the potential which is gonna be Vx is equal to infinity, 0 and infinity. Other than that, we are gonna have x less than equal to negative a by 2. X is going to be negative a by 2 and a by 2, and x is greater than equal to a by 2. This is what we are having. Looks like a different kind of expression, but it's quite familiar one. So if somebody is there who is finding what kind of expression it is, it looks like different, but it's not. It is something you already know about. So yeah, now the statement is the ground state wave function. I'll give you its similar and simple form, which you already know, but in the discussion part. Function of the particle, because if in the exam you will get this, you have to identify with the same expression. Particle is proportional to Options are sine pi x over 2a. Next is sine pi x over a. Next one is cos pi x over 2a. And next one is cos pi x over a. How many of you know the answer? You can just mention it in the comments if you know it. If no, then just in some time I'm gonna let you know what steps you have to take and how you can reach to the final answer for any such type of question. It's a concept which is very important for everyone to know and to understand it, because you can expect and you can have other questions similar to this in the exam too. So it's very, very, very much important. Very good, Pooja. That's great. So there is one answer till now, guys. I'm gonna wait for others too. Very good, Liana. 2 different answers we are having right now. So I'm gonna just clarify which one is correct. Don't worry if you are confused or you are getting different and somebody else is getting different, because I will be making it clear, but I'm gonna wait for everyone's response first. These are options and this is question. A quantum particle is subjected to the potential, the given potential. The ground state wave function of the particle is proportional to the sine pi x over 2a, sine pi x over a, cos pi x over 2a, cos pi x over a, whatever it will be according to you, just mention it. Very good, Kalyani. That's great. 2 students are saying it should be option C and 1 is saying it should be option D. So we will just see which one is correct exactly after the discussion, okay? Can I start the discussion and should I declare it? If somebody is there who is still working on this part and trying to get the answer, you can mention it in the comments, guys. Very good, Liana. That's great. Okay, let me just tell you. So exactly, it's going to be the form of potential they have given you, which is trying to say that only for this reason, okay, the potential value is 0. For all other reason here and there on both sides, it's gonna be infinity. So if I'm gonna draw it this way, it is negative a by 2, it is positive a by 2. Other than this range, at all other positions, the potential is infinity, right? In this case, the first thing we observe is it's a symmetric potential well, because about the origin on both sides, it's going to be same values of x we are having in the range, negative a by 2 and positive a by 2. So what does it mean? It means it's a symmetric potential well. And when it is a symmetric potential well, what will happen next? The next thing is you need to know the wave function. So wave function is quite different for the symmetric and the asymmetric cases. When it is a symmetric potential well, it's going to be root 2 by L. L is the length of the box. For example, it is negative a by 2 to positive a by 2. So a by 2 here, a by 2 here, which is just a. So length in this case will be a, okay? Root 2 by L cos n pi x by L. N is that value for which state you want to write the wave function. For example, for ground state, it takes value 1. For first excited state, it is gonna take the value 2 and that way. So root 2 by L cos n pi x by L for n odd. Odd means 1, 3, 5 and so on too. But at the same time, root 2 by L sine n pi x by L for the even n values. Means for n is equal to 2, 4, 6 and so on too, right? In this case, what will happen? If I'm going to talk about the even and odd, so what they're asking you to find for the ground state, right? So ground state means what? 1, okay, n is equal to 1. So what should be there in our wave function right now? It should be cos. So cos n value 1, that is pi x over L. What is the L value then? It's a, right? So in that case, cos pi x over a, root 2 by a. So in the cos part, we are just having pi x over a, which means option D is the correct one. Even if you will get any other question anytime, you have to take care of this part. What is the range? What is the length of the box? And what is the system? When you take care of this part and corresponding to odd and even values of n, what are the expressions for the wave function you will have? So when you take care of all this, you can easily get to know about it, that what will be the right expression and the answer for it. But if in case there is still any doubt you're gonna have, you can let me know and we will try to make it clear to you. But if everything is getting clear, I'll give you the next question. So tell me guys, is there anything you want to ask or something is not getting clear to you? You can just let me know. Waiting for your comments, whether you can mention clear or done, or you can tell me if there is any doubt. And accordingly, we will go ahead to discuss more. Waiting for your reply. And after that, we are going to go ahead to do more discussion. Is it done? Okay, next question is waiting for you if it's done. Should I start writing the next one? If you have any confusion or doubt for that, you can surely let me know. Yes, Kalyani, because your box was extended from negative a by 2 to positive a by 2, right? So if you are considering that box is having the length from this to this, so there are two types of range you will get. X lying between negative a by 2 to okay, let me just go back to that slide, which is here. So if they are saying, okay, the x is extended from negative a by 2 to positive a by 2, which means it's gonna be having the length a. Why? Because negative a by 2 to positive a by 2 length is a, right? Because both sides length you have to include. Other than that, they can say x is lying between 0 to a or 0 to a by 2. Then you are just gonna consider from 0, means your system is 0 to a, right? So this is the overall length, or if they will say a by 2, so a by 2. But depending on this case, you have to consider, if this is given, you have to include both sides. A by 2 and a by 2, that's giving you a overall. Kalyani, did you get the two conditions? This is symmetric case example. This is asymmetric case example. In asymmetric case, we are just having the one wave function, which is root 2 by a sine n pi x by 8. That's it. But in the symmetric case, as I've told you, two different wave functions. So you have to take care of this part in the symmetric case, but in asymmetric, do it easily. Tell me if there is any doubt now. Anything anybody else want to ask? If yes, we can talk about it. If no, we can go for the next question then. Tell me if you want to ask even anything else. Waiting for your reply, guys. Okay, great. Let's go over the next one. That's great. I'm just gonna check something here in the session. Okay. Cubic potential with the degeneracy of the fifth excited state of the particle is, and options are 3, 5, 6, and it's gonna be 7. Try it now and let me know whatever is the right answer according to you. I'll be waiting for your reply for some time, and then we will go over the discussion part together. Tell me whether you are getting it or not. And if yes, then what is the right answer according to you? Very good, Sarita. That's great. Let's wait for others' answer too. And then just in some time, I'm going to continue the discussion as well. So what answer is there till now, guys? Waiting. Oh, I have mentioned A, B, D, D. Whether it should be C. Even we will consider it to be C. Okay? A, B, C, D in sequence. How we can do this? But we can. We have done this. Okay. It's here. Waiting for your reply, guys. Only one answer is there, waiting for more. And then just in some time, I'm going to continue the discussion as well. So the question is saying that a free particle of mass m is located in a three-dimensional cubic potential well. So 3D cubic potential well or three-dimensional cubic box, something like that you can consider, with impenetrable walls. The degeneracy of the fifth excited state of the particle is, that's what we have to consider, right? So degeneracy of the fifth excited state. Before going ahead with the degeneracy discussion, it's very important to have the idea about the energy of the 3D case. Nx square plus ny square plus nz square pi square h cut square over 2 ml square. Now you will say why we are writing them together, like why we are not taking separate terms. So the reason is because we don't have the separate length given or the separate conditions given for the 3 dimensions. So we can write it together, that's all right? So once we are going to write it together, what will happen next? The next thing is we have to consider the fifth excited state energy. So first of all, we need to know that n values start from 1 for any such case. So if I'm going to talk about the ground state, for that what will happen? I can just allot the values 1, 1 and 1 to nx, ny and nz, right? So it will give me nx square plus ny square plus nz square. I'm just focusing on this part because this is going to remain same in all the cases. So it's not going to affect the energy, but the first three terms values will. So it is going to give us 3. If I will take 1, 2, 1, 2, 1, 1 or any such combination, it will give me 6, right? If I'm gonna take 1, 2, 2, what it will give me, and 1, 2, 3 or 1, 1, 3, what it will give me, let's check it out. 2 to the 4, 2 to the 4, 4, 4, 8 and 1, 9. This is gonna be smaller than the other value, hence I will prefer to take 1, 2, 2 first. So that's giving me what? Something. The value I'm writing, not the degeneracy, okay? So that's going to give me 9. And what about this one? 9, 10, 11. But if I will take 2 here, 2, 2, 2, what I'll get? 4, 4, 4, and that's going to be 12, right? And 9, 10, 11. So this is lesser value. I need to take it first. So there is no such thing that you have to consider the values as per this rule or that rule, but it should be in the increasing order always. There should not be any other value lying before the value you are trying to consider. Once you have reached to that value, now you have the two choices, 2, 2, 2 or 1, 2, 3. So I think 2, 2, 2 is giving us 12. So that should be considered first and then should be considered 1, 2, 3. So you can just even check it out if you are having any other choice or any other thing you want me to include in between. Let me just see what states we have considered till now. Ground, first excited, second excited, third excited, fourth excited, fifth excited is here. Okay, that's great. We reached to this point. 1, 2, 3, 2, 1, 3, 3, 1, 2. And it's shuffle these terms. 2, 3, 1. And shuffle these two. Okay. 3, 2, 1. Okay. Shuffle the first two, that is 1, 3, 2. We already had. No, we don't have 1, 3, 2 because these are nx, ny, nz values. So all these mean the different, right? So if I'm going to shuffle any other number now, like these two, the last two, 1, 2, 3 is already there. 3, 1, 2 is already there. 2, 1, 3 is already there. 1, 2, 3 is already there. So I can see I was able to make the 6 different combinations with it. And that was my fifth excited state. And you have observed that how I was able to write all these different combinations as per the ground state, first excited state, second excited state, and third or fourth, or then fifth. Done. So it is giving me the total different combinations possible for these values. That's going to be 6. And this is how I'm going to get the degeneracy for the fifth excited state as 6. Same way if you have to get for any other state, okay, you can simply write it by taking these combinations and by observing what are the different possibilities, how I can write it for different cases, and that will be helping you for sure. Tell me still if there is anybody having any doubt. I can try to make it clear to you guys, but if it is gonna be clear now, I can take the next question. So you can let me know if you have any question, query or doubt or anything you want to ask. We can go over that part then. Any doubt? Because I think only one student was able to answer it and that was a different answer. Okay, so still I'm gonna wait for your reply if you have any questions. Liana, shortcut is you can memorize for the all symmetric, like symmetric, I'm gonna say for the square well potential. What is the meaning of square well potential? That your Lx, Ly, Lz are equal. Okay, for 3D cases you can memorize those values anyway. For harmonic oscillator we are having a trick, that is n plus 1 or n plus 1 n plus 2 over 2, like that. But for the box generally we find it. Okay, so either you can memorize that sequence wise by finding it in advance, that okay, for ground state I'll have this, for first excited state I'll have this. So you can prepare it in advance so that you will have sequence, and for whatever state they are asking you, you can write it. So at least till fifth excited state you can prepare it. Okay, for some of the cases we are having tricks to find the degeneracy, and that's how it works. Is that okay and clear? For harmonic oscillator, like generally we go over the tricks. If still you have any doubt, you can tell me. Okay, let me just give you the another question now, guys. It's here, it's here, it's here. And even when you work on these things, you get to know, like, oh, this is how I have to go ahead and I can get the answer. So you start doing it quickly because you are not gonna make it explain to anyone in the exam. You are gonna do it for yourself, right? So in that case, you don't need to spend that much time and you will be just doing it quickly as well. Let's take this one. Let me just check something. That everything is all right or no? I think yes, 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 everything is all right and clear. That's better. 3 non-interacting bosonic particles of mass m each are in a one-dimensional infinite potential well of width a the energy of the third excited state of the system is x times h square pi square over ma square. The value of x is dash. Options are 2, 3, 4 and again D. Why? Where is the option C? It should be here. Okay guys, and 6. That's it. You can consider whatever is the right answer according to you. And I'm waiting for your reply, giving you some time to work on it and to give me the answer. But if you will not be able to get it or you will have doubt or difficulty in solving this part, I will be helping you. Don't worry about it then. But I want you to try once. And hope you are gonna get the answer too. Waiting for your reply, guys. And then just in some time, I'll be starting the discussion too. Nobody has given the answer till now. Waiting for your reply, guys. Try, and whatever you are gonna get, just mention it in the comments. Whatever is the right answer according to you. Otherwise, I'm gonna start the discussion too. So it is saying that three non-interacting bosonic particles of mass m each are in a one-dimensional infinite potential well of width a. System. What is the system? So 1D infinite potential well of width a. So one student has got it. Option. Okay, it's the answer written there. Option D. Correct. That's great. Now, if we are going to talk about this one, so firstly, you understood the system and you are also having the information about the width given, that's A. And how many particles are there? Three particles, right? And what kind of particles they are? Bosonic. Why it's important to focus on type of particles? Because if they are fermions, then as per the spin of the particle, which is half, you get to know 2s plus 1 is going to be 1 over 2 is the spin of the particles for fermions. It gives you 2. This is not fermion case, this is boson case, and there is no restriction for the number of bosons you can have in a particular state. So that's why once you got to know it's boson, you are free to enter 3 particles, 2 particles, 1 particle, any number of particle in a state, right? Now, the energy of the third excited state of the system is what? So in the ground state, let's say we are taking all the 3 particles in the lowest energy state. In the first excited state case, we are just rising up one particle to the next higher energy level. In the third excited state, when we want to consider what we can do, this is ground, this is first excited, and now second excited and third excited. These are the two possibilities we will have. So we are having this option or we are having this option. We just have to see which one is giving us the higher energy and which one is giving us the lower energy, right? So when you are going to consider, okay, Sakshi is getting option C, that's great, but we are just going to go through it, which one will exactly be the correct answer. So when you are considering this, what energy you will get? It is your n is equal to 1, the lowest energy level, then n is equal to 2, then n is equal to 3, right? So when you are going to consider it, n is equal to 1 square plus 1 particle there, 2 square plus 3 square, nx, ny, nz, right? So you are going to get 4, 9, 13 and 14. 14 here. And what about this one? It will give you 1 plus, it's going to be 2 particles there, 2 times the 2 square. So 4 to the 8, 8 and 1, 9, right? So you are getting 9 from this part. So you got 9 and you got 14, right? Now, since these are boson particles, we are not having any restrictions in this particular situation. So what else can be considered? This is your ground state. This is your first excited state. One of the other two will be your second excited state. So that will surely be the 9 one and not 14. And now we have to see, is there any other possibility we can have? So other than this, your one remaining particle which is there can also go to the n is equal to 2 state. Means your one more possibility you have to check out before considering 14 as the next value is this. So when you are taking all the 3 particles in the first excited state, means n is equal to 2, it will be giving you 3 times 2 to the 4, because 2 square you have to take pi square h square over 2ml square. So what it is going to give you, 3 4s are 12, 12 over 2, which is 6. So you can see 12 is greater than 9 but less than 14. So we can't jump to 14 directly. We have to firstly include 12 there. And that's how you're getting your option D to be correct. Reason: ground state this, first excited this, second excited this, and this is going to be your third excited state, because this condition was giving you more higher value. So third excited state energy is going to be 6 times the pi square h square over ma square. Please tell me, does it make sense and everybody is getting it clearly or no? Please let me know about it. Sakshi, is it clear to you and to everyone, guys, that the answer should be 6? And how you are arranging the particles, that's what I have shown you here. Tell me still if you are going to have doubt, I'll talk about it. Is this clear to everyone? That's great. If it will be clear, I'm going to take the next question, guys. And if you were missing something while you were working on it alone, okay, when I've given you time, so whatever mistake you were making, just be careful about it for the next time whenever you will solve any such type of question. So now we will take the next question. Let me just consider it. But still, if there was anybody having any doubt till that point of time, mention that, guys. I'll talk about it. Done, done, done. I'm gonna write the another one then. Here is your next question. The question says the energy eigenvalue, not value, values of a particle, excuse me, of mass m confined to a rigid one-dimensional box of width L R En for n is equal to 1, 2 and so on to if the walls of the box are moved very slowly towards each other. The rate of change of time dependent energy. I'll show you the previous slide once again. Time dependent energy, that is dE2 over dt of the first excited state is, options are E2 over L dL over dt, 2E2 over L dL over dt, negative 2E2 over L dL over dt, and the next one is negative E1 over L dl over dt. Try it now and let me know as you will get it done. If in case there will be anybody having any doubt, you can surely let me know about it. I'll go through that part and I'll try to make it clear to you as well. So waiting for your reply now. And if in case you will have any doubt, confusion or query, you can surely let me know. So giving you some time again to work on this question. Options are here, all the details have been given, whatever you need. Like such type of questions which you are going to do right now, they generally provide us more information and they generally give us everything we need, and that makes it quite simple and easy for us to solve any such type of questions. Waiting for your reply, guys. Nobody has mentioned the answer in the comments till now. I'm waiting for your reply, or otherwise, just in some time, I will be starting the discussion too. Still nobody has answered in the comments till now, guys. Whatever you are getting, whatever will be the right answer according to you, just mention it. Okay, because we are gonna go ahead to do the discussion then. Okay, even I think it's the time we should start the discussion. Or should I give you a little more time? The energy eigenvalues of a particle of mass m confined to a one-dimensional, rigid one-dimensional box of width L. Okay, 1D box and width L, that's easy. R, E, N, for n is equal to 1, 2, 3 and so on too. If the walls of the box are moved very slowly towards each other, then the rate of change of time dependent energy, dE2 over dt, we need to find. Great, great, great. And even if you're the one who is confused about this part, that what will change when they're moving towards each other slowly, then the length of the box, the width they have given you, that will change, right? So that's why even in the options, if you will observe, they have given you the terms like dl over dt. Why? Because that length is changing. So first of all, for 1D box, is it symmetric or asymmetric? Do you have any information? No. So you will take it asymmetric then. Just simply consider the energy for the n is equal to 2 state. Very good, Liana. That's great. And it is correct too. N square, which is 2 square, pi square, h square over 2 ml square. I need to take care of one more part. Did they mention the state? Yes, it's first excited state, so it's correct. I just have to take n is equal to 2. That's great. We are doing it right. So E2 is equal to what? That's going to be 4 pi square h square over 2 ml square, which is 2 pi square h square over 2 ml square. Just ml square, I simplified the 2 there. Next is, I just have to differentiate it with respect to t to get this d2 over dt, what they have asked us to find. So let's do the differentiation with respect to t now. And we know that only L is changing. So in that case, let's write overall everything as it is except L, because we will take it as L to the power -2 and differentiate it with respect to time. So it will give us n(x(n minus 1) form, which is -2L, -2 minus 1. And then we have to differentiate for it once again. That will give us simply dl over dt. So that's giving us negative 4 pi square h square over L cube. Yep, and m. And dl over dt. But you will see your answer is not given in this form. They have taken E2 there. So what I can do, I can try to write it in the form n square, that is 2 times the 2 square pi square h square over 2 ml square. I have taken that 2 here just because I wanted one more 2 in the denominator. So multiplied and divided by 2. Okay. and except that you will have the 1 over L dl over dt. I'm just modifying this form just to get it exactly in the same way how the options have been represented. So I'm gonna get, oh, where is negative sign? Let's take it back. It's here. Okay, negative 2. This is our E2 over L and then dl over dt. This is what we are gonna get. Negative 2 E2 over L dl over dt, where it is. Option C, and that's your correct answer. You can tell me still if you're gonna have doubt and you want me to explain anything, I'll talk about it then. But if everything is getting clear to every one of you, then that's great. And if there is anything you want to ask, you can surely let me know. I'll try to make it clear to you guys. And if you think you are gonna have a better command and you can do such type of questions easily now, I would like to give you a question for homework. If you want to practice it too, you can do it later on after the session as well. That will be all right. A particle, and I will even tell you the right answer for it so that you can just check it out later on once you will get that are you getting it right or no. Of mass m is confined to a box of unit length in one dimensional or dimension simply. It is described by the wave function sin x is equal to root 8 over 5 sin pi x 1 plus cos pi x for x lying between 0 and 1 and 0 outside. This interval wait a second. I'm just gonna see whether audio and everything is clear or no. Okay. It's fine. Done. So actually, next thing is interval. The expectation value of energy in this state is okay, and the options are, okay, I just need to write the options here. 4 pi square over 3m h squared square. Option B is 4 pi square over 5m h squared square, and 2 pi square over 5m h squared square, and option D is 8 pi square over 5m h squared square. Now the point is what will be your right answer and what you will get. So most probably you are going to get option B for this question. You can just work on it and you can see that whether you are getting it or no. If no, I'll be trying to let you know. You can ask about it in the next session. Okay, and that's how like we can consider it. Clear? So let me know if in case you will have any question or any query anywhere. We will talk about that soon in the upcoming session. And if everything is clear, guys, then that's great. So let's keep it this much right now in the session, as I have shown you some slides in the starting of the session. This is regarding the Iconic subscription. You will be able to get the discount by using and by applying the code Anjali Live as mentioned here on the screen. So whenever you will go ahead to take the subscription, you can use and apply the code that's Anjali Live as mentioned here. And even you can take the plus subscription. It's up to you, whichever you find more beneficial for yourself. The details about the Unacademy Plus, Iconic and the Lite subscription have been shown here on the screen. In the Plus and the Iconic subscription, you will also be getting the notes which will help you to take your preparation to the next level. Okay, so let's keep it this much right now, guys. Thank you so much everyone for joining this session and for attending it till the end. Thank you. Bye. Take care. And anytime, whenever anybody will go ahead to take the subscription, use and apply the code Anjali Live to get the discount in the total subscription amount. Thank you so much everyone. We will have so many other sessions too where we will talk about different subjects, most important questions, concepts and tricks. So don't miss them. Okay. And even new courses are starting on Unacademy. So if you don't want to miss them, you can take the subscription.